No, a 2-screw Romex connector is not suitable for securing a ground or bonding wire, specifically THHN, from a grounding electrode or water main into a panel. The National Electrical Code, specifically Article 250.148c, addresses this directly. It mandates that grounding electrodes and bonding jumpers must be connected using approved connectors or clamps of the solderless type. This requirement exists to ensure a reliable and permanent electrical connection for grounding and bonding systems, which are crucial for safety. A 2-screw Romex connector is designed primarily for securing non-metallic sheath cable, often referred to as Romex, to electrical boxes or enclosures. These connectors typically have a plastic or metallic body with 2 screws that tighten to clamp the cable. They are not intended or listed for grounding or bonding purposes, mainly because they don't provide the necessary contact area and mechanical strength to maintain a reliable, low-impedance connection over time, especially when dealing with grounding conductors. Grounding and bonding systems are essential for providing a safe path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to operate and clear the fault. A high-resistance connection in the grounding path can impede this process, potentially leading to dangerous voltage levels on metal parts of equipment and increasing the risk of electrical shock. Article 250.148c of the NEC emphasizes the use of approved connectors or clamps specifically designed and listed for grounding and bonding applications. These connectors are typically made of copper or aluminum alloys and are designed to provide a secure, corrosion-resistant, and low-impedance connection. They are often listed to standards such as UL 467, which covers grounding and bonding equipment. Approved connectors and clamps for grounding electrodes and bonding jumpers come in various forms, depending on the specific application and the type of grounding electrode or conductor being used. Here are some common examples. Firstly, ground clamps are used to connect grounding conductors to grounding electrodes such as ground rods, water pipes, or metallic building frames. These clamps are typically made of bronze or copper alloy and are designed to provide a secure mechanical and electrical connection to the grounding electrode. They are available in various sizes to accommodate different sizes of grounding conductors and electrodes. Secondly, bonding jumpers are used to connect different metallic parts of a system together to ensure electrical continuity and create a low-impedance path for fault current. Bonding jumpers are typically made of copper wire or strap and are connected using approved connectors such as bolted connections, compression connectors, or exothermic welds. Thirdly, compression connectors are used to create a permanent, solderless connection between grounding conductors. These connectors are typically made of copper or aluminum and are installed using a crimping tool that compresses the connector onto the conductor, creating a tight, gas-tight seal. Compression connectors are often used in high vibration or corrosive environments where a reliable connection is critical. Fourthly, exothermic welding, also known as cat weld, is a process that uses a chemical reaction to create a permanent molecular bond between grounding conductors. This method involves placing the conductors in a mold and then igniting a special compound that melts the conductors together, forming a solid, corrosion-resistant connection. Exothermic welding is often used for grounding electrodes and for creating low-resistance connections in critical grounding systems. Fifthly, split-bolt connectors are sometimes used for splicing or tapping grounding conductors. These connectors consist of 2 halves that are bolted together, clamping the conductors between them. While split-bolt connectors can be used for grounding, it's crucial to ensure that they are listed for grounding applications and are properly installed and tightened to maintain a reliable connection. Sixthly, lay-in lugs are another type of connector used for grounding, particularly in panels and enclosures. These lugs allow the grounding conductor to be laid into the lug without having to thread the conductor through a hole, making installation easier. Lay-in lugs are typically used for connecting equipment grounding conductors to the grounding busbar in a panel. When selecting a connector or clamp for grounding and bonding applications, it's important to consider several factors. Firstly, the connector or clamp must be listed for grounding and bonding purposes, meaning it has been tested and certified by recognized testing laboratories such as UL or ETL. Secondly, the connector or clamp must be compatible with the size and type of grounding conductor being used. Thirdly, the connector or clamp must be suitable for the environment in which it will be installed, taking into account factors such as corrosion, vibration, and temperature. Fourthly, the connector or clamp must be installed according to the manufacturer's instructions and using the proper tools. The NEC provides detailed requirements for grounding and bonding in Article 250, which covers various aspects of grounding and bonding systems, including the size and type of grounding conductors, the methods of grounding electrodes, and the requirements for bonding different metallic parts of a system. Here is a breakdown of some relevant sections within Article 250. Firstly, Section 250.4 addresses general requirements for grounding and bonding, emphasizing the need for a permanent and effective grounding path. It specifies that the grounding path must be capable of safely carrying the maximum fault current likely to be imposed on it. Secondly, Section 250.8 covers the connection of grounding and bonding equipment, reiterating the requirement for approved connectors and clamps of the solderless type. It also prohibits the use of methods that rely solely on solder for making grounding connections. Thirdly, Section 250.50 addresses grounding electrode systems, specifying the types of grounding electrodes that are permitted, such as metal water pipes, metal building frames, and ground rods. It also specifies the requirements for the size and installation of grounding electrodes. Fourthly, Section 250.64 covers the grounding electrode conductor, which is the conductor that connects the grounding electrode to the electrical system. It specifies the size and type of conductor that must be used and the methods for protecting it from physical damage. Fifthly, Section 250.92 addresses bonding of metal enclosures and raceways, requiring that all metal enclosures and raceways containing electrical conductors be bonded together to create a continuous electrical path. This bonding helps to minimize voltage differences between different metal parts and reduces the risk of electrical shock. Sixthly, Section 250.104 covers bonding of piping systems and exposed structural metal, requiring that metal water piping systems and exposed structural metal that are likely to become energized be bonded to the electrical system. This bonding helps to prevent electrical shock hazards and ensures that fault current can safely return to the source. In summary, using a 2-screw Romex connector for grounding or bonding conductors is a violation of the NEC. Grounding and bonding connections must be made with approved connectors or clamps specifically designed and listed for those applications. These connectors provide a secure, reliable, and low-impedance connection that is essential for the safe and effective operation of electrical systems. Always refer to the NEC and consult with a qualified electrician to ensure that grounding and bonding systems are installed correctly and in accordance with all applicable codes and standards.